Okay guys, so for our first problem, so sabay-sabay natin basahin. Water flows in a 40 mm diameter pipe at a velocity of 0.5 meter per second. So we need to determine the following. So the first one is the volumetric flow rate. The next one is the mass flow rate. And the third one will be the weight flow rate. So let's start first drawing the figures. So again, meron ka daw ditong pipe. Ayan. So sinabi naman na uniform yung diameter niya. So the diameter of this pipe is 40 mm. So guys, tandaan nyo that usually ang binibigay sa problem is yung nominal diameter. When we say the nominal diameter, this is the inside diameter of the pipe. And tandaan nyo na iba yung outer diameter sa inner diameter. And ang kailangan natin gamitin sa equation ng volumetric or whatever flow rate is the inside diameter. So kapag sinabi guys na in-indicate sa problem na ang given is yung outer diameter at nagbigay siya ng thickness ng inyong pipe, so kailangan mo pang kunin yung inner diameter. Again, emphasize ko lang, yung 40 mm is the nominal or the inner diameter. Aside from that, yung flow ng tubig mo ay tumatakbo at a velocity of 0.5 meter per second. So in diameter guys, i-convert na lang natin ito agad sa sa meter para ma-satisfy natin yung mga units. So, 40, just divide this by 1,000 para ma-convert mo siya into meter. Or this is equals lang sa 0.4 or, no, sorry, 1,000 nga pala. 0.04 meter. Alright? So, for letter A, again, ang hinahanap dito is yung volumetric flow rate or yung mas kilala sa tawag na Q sub V. So again, ano yung formula natin? Diba yan ay equals lang sa area times the velocity. Kung saan yung area, this is just the section ng iyong pipe. So kapag tinignan mo yan sa tagiliran, ang makikita mo is in the shape of a triangle. So that will be equals lang sa pi over 4 times 0.04 squared times the velocity na 0.5 meter per second. So pindutin lang natin sa ALQ. So sabayan nyo ako habang nagdi-discuss. So that will be pi over 4. So pi over 4 times 0.04 squared times 0.5. So ano na palabas ninyo? So yung napalabas ko is 6.2832 times 10 to the negative 4 cubic meter per second. So kung yung ipahanap sa inyo ay in liters per second, so ang conversion niya in 1 cubic meter there is 1,000 liters. So i-multiply nyo lang ng 1,000 para mauha mo siya in terms of liter per second. So ang ating answer is 0.6283 liter per second. So this is our answer for letter A. The next, isolve naman natin yung for letter B or para kay mass flow rate. So again, for letter B, ang ating equation lang ay equals lang siya saan, di ba? Q sub M or the mass flow rate is equals to mass over the time. Or di ba equals lang din siya sa rho multiply by Q sub V or the volumetric flow rate. So ang gawin nyo na lang dito guys, i-store nyo na lang yung sagot natin in cubic meter per second. Okay? Or yung answer natin na 6.2832 times 10 to the negative 4. So shift and then store and then assign mo siya on any value. So gagawin ko, store ko na lang siya sa letter A. So ang density niya, ano nga yung density natin for water? Diba, yung raw for water is equals lang sa 1,000 kilogram per cubic meter. And then, i-multiply mo lang yung sagot natin dito, which is 6.2832 times 10 to the negative 4 cubic meter per second. So, cancel out mo na lang to. And then, ang matitira na lang sa kanya is kilogram per second. So, nasatisfy natin yung unit mo for mass flow rate. So the answer for that one is equals lang saan? So that is equals to 0.02 6283 kilogram per second. So this is our answer for letter B. And last will be for the weight flow rate. So for the weight flow rate, so again, na-discuss naman natin yan. So ang equation niya is Q sub W, so to denote the weight flow rate, is equals to the gamma of the water multiplied by the volumetric flow rate. So again, ang ating gamma is equals lang saan? Diba ang gamma is equals to 9.81 kilonewton per cubic meter. So equals lang din siya para masatisfy natin yung units niya in terms of Newton. So equals lang din siya sa 9810 Newton per cubic meter. Okay, so ang gawin na lang natin is ito yung gamitin natin para yung answer na makuha natin is in terms of Newton. So Q sub W is equals lang sa 9810 Newton per cubic meter and then multiply by the volumetric flow rate na 6.2832 times 10 to the negative 4 cubic meter per second. Again, cancel mo lang yung cubic meter. So, ang natira na lang is in Newton per second. So, the answer for that is equals lang sa 6.1638 Newton per second. Okay, so madali lang na. So, simulan mo na sa mga pinakamadaling problem. So, let's proceed with the next problem. Okay, so for our problem number 2, so we have here a pipe system shown. So, determine the diameter of pipe number 2 from this figure. So, given ay ang mga sumusunod. So, una, meron tayong ditong inflow ng tubig. So, that is the flow rate from Q1. And then, anong nangyari? Lumabas siya dito sa Q3 and Q2. So, from that, makaka-establish tayo ng equation from which yung Q1 mo or the inflow is equals lang sa outflow na Q2 plus Q3. And then, again, alam natin na yung flow rate mo is equals lang sa area times the velocity. So, aside from that, ang given sa Q3 mo, given yung diameter niya na 500 mm yata ito. So, ano lang natin na 500. And then, yung velocity niya, so given naman na 1.5 meter per second. So, dun sa 2, the velocity there is 0.51 meter per second. And again, ang required nga natin hanapin dito is yung diameter ng pipe 2. Okay, so input lang natin dito sa equation na to. Napakadali lang naman ito. So 0.69 cubic meter per second, so ito yung para kay Q1, is equals do sa Q sub 2, kung saan A times B nga, or pi over 4, times the diameter of our pipe number 2, and then squared times the velocity of section 2, so 0.5 meter per second. And then plus Q sub 3, or that will be pi over 4. So, gawin natin yung 500 mm, i-convert na lang natin to meter. So, simply, i-divide mo lang siya ng 1,000 para maging meter. So, pi over 4 times 500 over 1,000 squared. And then, times the velocity. So, given lang din naman sa problem na 1.5 meter per second. Alright, so, input mo lang to sa calcu. And then, i-shift solve natin. So, sabayan nyo ulit ako. 0.69 is equals to pi divided by 4. So, pi divided by 4 times t squared. So, inilet ko na lang siyang x. So, times 0.51 plus pi over 4 times 500 divided by 1,000 squared times 1.5. And then, shift solve. So, guys, para mabilis lang din pumindot yung calcu nyo, maganda kasi inputan mo to ng value. Paglaki nung natansya mong answer do sa sagot na ibibigay ni calcu, pagbilis niya. Kasi ang nangyayari dyan, kung 0 yung input mo, iisa-isahin niyang hanapin yung sagot. And then siya, nagbrowse siya, sabay siya from positive to negative. So, tandaan nyo, ito ina-squared. So, ibig sabihin, dalawa yung pwede maging sagot. Maaring negative yung una niya ibigay or maaring positive. Kaya mas maganda, mag-input ka ng value for the value of D. So, ang naghanap sa akin ng value ng X, so gawin ko na lang na 1. Ayan. So, ang lumabas sa akin, ano lumabas sa inyo? So, napindot ko is around 0.9936 meters. Okay? Pero in actual, so ito naman kasi, pwede mo rin kasi siyang i-round up kung i-consider mo in actual yan. Kasi wala ka namang mabibili sa hardware na ganito eh, na ganitong size. Pabili naman ako ng 993.6 millimeter diameter na pipe. So, lagi siyang merong cut-off na maring sa commercial market, ang mabibili mong standard size yan is in terms of 100 mm. So guys, tandaan na laging ang round up mo is pataas ha, wag paliit. Kasi nga, ito yung ano niya eh. Ito yung required diameter. So kung any value na lilit dito, so hindi mo masasatisfy itong condition. So lakihan mo na lang. Ano? So yun lang. Pero sa exam, ito, acceptable naman to, lalo sa board exam. Ayan. So okay, so let's proceed with the next problem. Okay, so for problem number 3, basahin natin. So determine the total energy head of water flowing in a 100 millimeter diameter horizontal pipe at a rate of 15. So LPS stands for liter per second and having a pressure of 150 kilopascal. If the elevation of pipe is at 20 meter above the ground level, ayun nga, hindi pa tanong yun. So, okay. So, ang required sa problem is to determine the total energy head. Okay? So, alam naman natin yung total energy head has an equation of E sub T is equals to ano nga equation natin? So, yung velocity head mo na B squared over 2G plus yung pressure head na P over gamma and yung elevation head na Z. Okay, so before that, it's required na para mas madali rin natin ma-analyze siya. Drawing muna natin yung figure. So, drawing lang natin. So, meron ka daw, tandaan nyo, mahalaga yung bawat statement to sa problem. So, sabi dyan, horizontal pipe. So, when say horizontal, nakahiga lang yung pipe mo. Ayan. And, ano pang given dyan? So, given dyan sa problem is yung diameter. Yeah. So, most probably, this is the nominal diameter. So, given yung diameter niya na 100 mm diameter pipe. And yung rate ng inflow niya and yung outflow, so the Q is given as 15 liter per second. So, maganda, i-convert na natin yung 15 liter per second niya in terms of cubic meter per second. So, i-multiply mo lang ng, again, ano nga ang value niya? In 1 cubic meter, there is 1,000 liter. Or that will be equals lang saan? So, 0.015 cubic meter per second. So, ang hinahabol nga nating mga units is in terms of meter. And then itong 100 mm, so divide mo lang din ng 1,000 or that will be equals lang sa 0.1 meter. Okay? So, ang sabi dyan, meron ka daw na datum. So, ang sabi, yung pipe mo is 20 meters above ground level. So, ito yung sinat nating datum line. Datum line. So, ang Z niya, o yung elevation head, is given as 20 meters. Alright? Okay? So, lagyan lang natin ng point dito. So, diba dun sa, kung naalala nyo yung ating previous lecture, ito kasi, magkaaroon siya ng equivalent na pressure head. So, since ano yan, flow in pipe, so alam naman natin na sa loob ng pipe, meron kang existing pressure. So, itong height na to, ayan, so i-denote na lang natin siya as the pressure head, P over gamma. And since flow in pipe yan, so again, maliit yung diameter, so meron siyang magiging velocity head. B squared all over 2G. So, ito yung ating total energy. Ayan, E sub T. So, kaya naging ganito rin yung ating equation. Okay, so I think kompleto na naman yung ating mga given. So, given naman yung pressure, diameter, flow rate, etc. Okay, so apply lang natin yung equation. So, E sub T. Sorry. Pwede natin blue. So, E sub T is equals to sa velocity head. So, given naman yung velocity again. So, asan nga pala si velocity? Wala. So, alam naman natin again, guys, na pero given yung yung flow rate. Alam natin again na V, Q is equals to A times B. So to solve for the velocity, so that will be equals lang sa Q over A. Or i-simplify muna natin. So 0.015, ito, divided by yung area, which is pipe naman yan. So circular yung section, pi over 4. And binigay naman yung diameters times 0.1 squared. So, ano muna natin? Kunin muna natin yung value para hindi masyado malaki yung isusulat natin ito. 0.015 times 4 divided by pi divided by 0.1 squared. So, yun nakuha ang velocity. Ano yung napindot nyo? So, 1.9099. So, guys, tatandaan nyo ha, kapag nag-round off kayo, at least 4 decimal place. Sa pagdami kasi ng decimal places mo, pag-accurate ng answer. Okay, so that is meter per second. So, gawin ko, store ko na lang siya sa A para hindi ako pindot ng pindot. Ano? So, store. Alright, so, balik tayo dito sa equation. So, ito nga. So, B squared over 2G. So, 2 times the gravitational acceleration na 9.81 meter per second squared. And then plus the pressure head. So, given ka ng 150 kilopascal or kilonewton per square meter over the unit weight of the water. So, 9.81. So, kilonewton per cubic meter. So, okay lang yan. Ma-answer naman yung mga unit. So, ito minus 2. Kaya magiging 1, which satisfies. So, reciprocate mo lang. So, tataas yung meter. So, meter tayo. And then, plus our elevation head na 20 meters. So, input mo lang to sa CalQ. And what will be the answer for our total energy head? So, yung alpha ko, V squared over 2G or 19.62 divided by 19.62 plus the pressure head na 150 divided by 9.81 and then plus 20. So what is the answer for the total energy head? So yung napindot ko guys, ano napindot nyo? So nakuha ko is 35.4764 meters. So ayun lang yan. Box mo lang and then check. So let's proceed with the next problem.